The process of smelting iron from its centers in the blast furnace. Into the top of this great furnace goes the iron ore, together with certain other raw materials, and out of the bottom comes glowing hot liquid iron. A modern blast furnace using rich ore can produce 1,000 tons of iron in a day, so you can see quite a lot of raw material is needed. In fact, every hour that one of these blast furnaces works, it uses about 80 tons or more of ore, depending on how rich in iron it is, 32 tons of coke, as well as 20 tons of limestone to help carry off certain impurities, and air, about 160 tons of air every hour. That's as much as there is in a cube about 80 feet high. This is the air which is blown in at the bottom of the furnace to furnish the blast. But let's take a look at the inside of a blast furnace and see how it's built up. The main part is a hollow steel shaft lined with fire brick called the stack. This is normally full of layers of iron ore, coke and limestone. The air blast is supplied by powerful blowers. But before it enters the furnace, it is heated up in tall stoves which stand beside the blast furnace. From here, the hot blast goes to the bustle main, a large steel pipe lined with fire brick which runs right round the blast furnace. However, since this is a sectional drawing, we'll cut out the part in front. From the bustle main branch pipes to the tuyers, the water-cooled nozzles which lead the air into the blast furnace. We can only show two, but actually they're set all round. You can see it better on the real thing. Here is the bustle main, and here are some of the tuyer pipes branching from it, set 4 or 5 feet apart. The blast is blowing into the furnace, but we don't want the hot gases which are produced during the smelting to come pouring out of the top. On the other hand, we've got to get charges of coke and ore and limestone in somehow, so we pipe the gases off, like this, and build a sort of one-way valve which will let in the raw materials, or the burden as it's called, but won't let the gases out. Here's how it works. There are 2 steel bells which can be moved up and down, a large one and a small one. A skip empties its load onto the small upper bell. Then this is lowered, the load slides off onto the large bell, and the small bell is closed. This is usually done 2 or 3 times. When there is the correct amount on the large bell, it opens, and the whole lot slides off into the furnace. But the gases can't get out into the open air, as the small bell is always kept shut when the large bell is open. Watch it happen again. Small bell opens, shuts, large bell opens and shuts. But how does the blast furnace get the iron out of the iron ore? You might wonder that to yourself when you see the bins of ore. Well, smelting iron is a chemical process. No matter how you pick and scrape at a piece of ironstone, you'll never find any metal in it. The iron is there as a chemical compound of iron and oxygen called iron oxide. It doesn't look or behave anything like iron, and it's even less like oxygen, which is part of the air we breathe. Now, you probably know that everything is made up of atoms. There are millions and millions in each of the grains of ore you can see here. The atoms themselves are much too small ever to be seen, but we can draw a picture which will help us to understand them. We'll show an iron atom as a little ball, and we'll label it Fe, which is the chemist's shorthand for iron. A piece of pure iron is made up of millions of atoms arranged something like this. But iron ore contains atoms of oxygen as well. Atoms of oxygen are joined to atoms of iron to make units called molecules of iron oxide. There are various types in nature. The commonest form can be shown like this. The atoms are combined in the proportion of 2 of iron to 3 of oxygen. Another form, the magnetic oxide of iron, has the atoms combined in the proportion of 3 of iron to 4 of oxygen. But to keep our explanation as clear as possible, we're going to stick to the simplest kind, where 1 atom of iron is joined to 1 of oxygen. When atoms are chemically combined like this, they're joined together very firmly. So, to get the iron away from the oxygen, we have to do something pretty drastic. The drastic something we do is to make them very hot by heating them up with burning coke in the blast furnace. The only places you can see into a blast furnace when it's working are through little colored glass windows at the ends of the tuya pipes. Looking through, you can see the coke burning at white heat where the hot blast first reaches it. This is the first link in the chain of events which gets the iron out of the ore. When something gets hot, it means that the atoms are vibrating violently, and because they're being shaken about like this, it often happens that chemical compounds are broken up and new ones formed. And that is just what happens in the blast furnace. Here's an example of the simplest kind of chemical reaction which takes place. The chemically combined atoms of iron and oxygen are vibrating very strongly, and so are the atoms of the element carbon, which makes up most of the coke. An atom of oxygen breaks away from an iron atom and joins instead onto an atom of carbon from the coke. Now, it happens that oxygen atoms are drawn more strongly to carbon atoms than they are to iron atoms. So, bit by bit, the oxygen is transferred from the iron to the carbon, with which it makes a gas called carbon monoxide. The free iron atoms drop down inside the furnace as molten iron metal, while the carbon monoxide gas is carried away up the stack. This is the simplest of the many chemical reactions which go on inside the blast furnace. They all lead to the oxygen atoms being separated from the iron atoms and joining instead carbon atoms, which are carried away as gas. Written in chemist's shorthand, the reaction we've described goes like this. A molecule of iron oxide and an atom of carbon make an atom of iron and a molecule of carbon monoxide. This simple reaction takes place in the lower part of the furnace where it's hottest. But generally, most of the ore is smelted higher up the stack by another reaction. This happens in 2 stages. First, the carbon atoms burn. That is, they combine with oxygen in the blast to make molecules of carbon monoxide. Next, some of this carbon monoxide gas reacts with the molecules of iron oxide to make iron metal and carbon dioxide gas. So much for the iron ore and coke. But we said at the beginning that limestone also went to make up the burden. Why put that into the blast furnace, since it doesn't play any part in getting the iron out of the ore? Well, unfortunately, iron ore always contains a lot of earthy material, sand and grit, what we call the gangue. And if you've ever raked out a coke-fired boiler, you'll know that when coke burns, it leaves quite a lot of ash and clinker. Have you ever thought what it would be like to have to rake out a blast furnace? Well, that's where the limestone comes in. It's fed into the blast furnace and combines with the ash and the gangue. This makes it possible for them to melt inside the blast furnace to form a liquid which collects in the hearth at the bottom. This is what we call a slag. It can be tapped from time to time. Producing a slag of the right consistency is a job which needs a great deal of skill. We can now look at the process as a whole. The hot air blast enters the furnace at the bottom, where the coke burns and produces intense heat. The whole charge in the part called the Bosch here is at a temperature of about 1150 degrees centigrade, rising to 1900 degrees opposite the tuyeres. As the white-hot gases stream up the stack, they heat the burden, and in so doing lose heat themselves, so that they're progressively less and less hot the nearer they are to the top. At the very top, where the gases leave the furnace and the cold raw materials go in, the temperature is only about 250 degrees, well below red heat. You can see there's a two-way flow inside the furnace. The gases travel upwards, getting cooler as they give up their heat to the burden. The burden travels downward, getting hotter as it picks up heat from the gases. As the burden gets hotter, it eventually reaches a temperature at which the chemical reactions of smelting can start, and molten metal and slag begin to collect in the hearth. By the way, the hearth doesn't only contain liquid. As we show, it's filled with lumps of unburned coke, which hold up the rest of the burden. When enough iron has collected in the hearth of the furnace, the tap hole is opened and the molten metal runs off. It's not pure iron. It contains about 4% of carbon picked up from the coke, as well as other impurities. It's the job of the steelworks to get rid of them. But the blast furnace has finished its work. We have seen how the raw materials, ore, coke, and limestone, are fed into the top. How the coke, burning in the hot air blast, heats the burden as it slowly slips down the furnace until it's hot enough for the chemical reactions to take place which transfer oxygen atoms from the iron to atoms of carbon. Often the molten iron is taken straight to the steelworks as hot metal. It's carried in big ladles lined with fire brick. These are then taken to the melting shop, where the hot metal is purified and is converted into steel.